It's time to get ready for our Unit 5 test over square root functions. We'll start off by drawing the parent function, the y equals square root of x. As a reminder, we'll start at 0, 0 because the square root of 0 is 0. But when we go right 1, we'll go up 1 because the square root of 1 is 1. When we go right 4, I skipped over 2 and 3 because you can't take the square root of 2 and 3 perfectly. But when I go right 4, the square root of 4 is 2, we'll go up 2. And so it started 0, 0, 1, 1, and then 2, 3, 4, 1, 2. And here's the parent function of y equals square root of x. And so it has a starting point, and then it goes up and to the right. It's kind of like a half of a parabola, a sideways parabola. And so there's my parent function, the domain and range. For the domain, it starts at 0 and goes to the right, and so it's from 0 to infinity. Another way to write that is x is greater than or equal to 0. For my range, it starts at 0 and goes up to infinity. So again, it's 0 to infinity, or another way you can write that is y is greater than or equal to 0. It needs to be the brackets or have the equals bar because it is inclusive. All right, number 2. X minus 4 inside the square root goes right 4. And then down 1. That minus 1 on the outside goes down 1. So we're going to go right 4, 1, 2, 3, 4, down 1. There's my new starting point. And then we'll use these base points from number 1. When I go right 1, there's no stretch or compress. So we're going to go right 1 and up 1. And right 4, 1, 2, 3, 4, up 2. These points are always from the starting point. It's not from the previous one, it's from the starting point. So we'll go up and to the right from there. And there's my changed graph. For the domain and range, the domain, this one starts at 4 and goes to the right to infinity. Another way you can write that is x is greater than or equal to 4. My range starts at -1 and goes up to infinity, or y is greater than or equal to -1. There's my domain and range. As far as the x and y intercepts, in order to find the x-intercept is where it crosses the x-axis, and so we can clearly see it's right here at 5, 0, so you can just see it from the graph. For the y-intercept, it never crosses the y-axis, so it's no y-intercept, no solution, and so none. If you wanted to work it out algebraically, maybe you didn't have the graph, the x-intercept is where it crosses the x-axis, so my y value is 0, so we'll plug in a 0 for y, and we'll solve for x. And so solving for x, we're going to add 1 over. We'll get rid of the square root by squaring both sides. And then we'll add the 4 over. So 5 equals x, and that's what we have for the x-intercept. For the y-intercept is where it crosses the y-axis, so my x is 0. And so we'll plug in 0 for x. And we'll solve for the y. We'll just evaluate. 0 minus 4 is the square root of -4. You can't take the square root of -4 because that's imaginary. It's a no solution. That's why it's a none right there. All right, number 3. X plus 5. Let's list transformations first. The negative is going to reflect it over the x-axis. The 2 is going to be a vertical stretch by 2. The x plus 5 is going to go left 5. And then the plus 3 at the end goes up 3. So we're going to left 5, 1, 2, 3, 4, 5, up 3, 1, 2, 3. And then this one's going to be going down, but also as a reminder from my starting point, when I go right 1, normally we go up 1, but on this one we're going to multiply by the stretch of -2, so we're actually going to go down 2. So we'll go right 1 and 1, 2. And you can always use your calculator for this as well. Graph it in your calculator. When we go right 4, this is from number 1. Normally we go up 2, however we're multiplying by that -2 to make it go down 4. So 1, 2, 3, 4, 1, 2, 3, 4. So on this one I can't clearly tell exactly where my intercepts are. We'll find those in just a minute. But for my domain and range, my domain is going to be starting at -5 all the way to the right to infinity, so x is greater than or equal to -5. My range goes down to -infinity, and the highest point on this one is at 3. So y is less than or equal to 3. Now for the x and y intercepts. You can always use your calculator for it, and I'll show you the calculator next, but I'll do it algebraically first. So for the x-intercept, again, we're going to plug in 0 for y, and we'll solve for x. And so we'll subtract 3 over, so negative 3 equals negative 2 square root of x plus 5. We'll divide by that negative 2, so it becomes 3 over 2 equals square root of x plus 5. And then we'll square both sides. So when you square this, that square goes with both numerator and denominator, so it becomes 9 over 4 equals x plus 5, which now it gets a little bit easier. Just change it to a decimal. If you're not sure what it is, 9 over 4, you can just put in your calculator 9 divided by 4, and it tells me it's 2.25, and so we're going to do 2.25, and then we're going to subtract over that 5 equals x, and so we'll subtract 5, and that's my x-intercept, negative 2.75. My y-intercept will plug in 0 for x. And just evaluate. And so this is ready. We're just going to put it in the calculator as it is. And so negative 2 square root of 0 plus 5 plus 3 on the outside. There's my y-intercept, which makes sense too. So 0, negative 1.47. And we can check this in the calculator too. So let's put it in the calculator and just check our work, make sure that we did do it right. So negative 2 square root of x plus 5 plus 3. We'll graph it. Looks pretty similar to my graph. All right. The easiest ones to find is the y-intercept will go to the table. So second graph goes into my table. When x is 0, my y is negative 1.47, so we got that one correct. For the x-intercept, it's a decimal. I can't really see the decimals on here. I could change it, but I'll just come into the graph and we'll find that x-intercept. So we're going to go to calculate, second trace or second calculate. We want to find the x-intercept, which 0 is another word for that. And now we want to trap that x-intercept. So we'll go to the left side, press enter, go to the right side, press enter. And now it'll find that x-intercept in between negative 2.75. We got it correct. So there's how to do it algebraically and also in your calculator. Number 4, find the inverse of the following. We're going to switch our x and y. So there's my y right here. So x equals square root of y minus 4 plus 3. We'll subtract the 3 over. We'll get rid of the square root by squaring both sides. And then add 4 over. So y equals x minus 3 squared plus 4. Another way you can do this easily is just everything's going to switch location and operation. So the minus 4 on the inside turn to a plus 4 on the outside. Plus 3 on the outside turn to a minus 3 on the inside. Square root changed to a squared. That's all you're doing. And so I'll show my work though. I want to make sure you're ready for this test. Y minus 1 squared plus 7. We'll subtract 7 over. We'll get rid of the square by doing the square root. And when we do the square root, we'll put a plus or minus in front. And then last step, we'll add that 1 over. So plus or minus square root of x minus 7 plus 1 is equal to my y. And then last one, and again, the minus 1 on the inside turned to a plus 1 on the outside, plus 7 on the outside, minus 7 on the inside, squared turned into square root. Everything changes location and operation. So x equals negative 2 square root of y plus 6 minus 2. We'll add the 2 over. We'll get rid of this negative 2 by dividing by negative 2. And then we're going to square both sides. So I'll come out over here. So we've got x plus 2 over negative 2 squared is equal to y plus 6. Then we'll subtract 6 and we're done. So the plus 6 on the inside turned to minus 6 on the outside, minus 2 on the outside turned to plus 2 on the inside, and this negative 2 is currently being multiplied on the outside. The opposite of multiplying on the outside is dividing on the inside, and then square root turned to squared. All right, number 7, we're back to what we did on the front. And so x plus 3 is going to go left 3, 1, 2, 3, plus 2 goes up 2, 1, 2. And then this one is reflected, so I'm going to go right 1 and down 1, right 4, 1, 2, 3, 4, and down 2. My domain starts at -3 and goes to infinity, or x is greater than or equal to -3. My range goes down to -infinity and goes up to 2. So my y is less than or equal to 2. My x-intercept I can clearly see is 1. I know it's going to be 1, but we'll also do it algebraically. Y-intercept, I'm not exactly sure. It's somewhere between 0 and 1, and so we'll find that one. All right, so for my x-intercept, we'll plug in 0 for y, and we'll solve for x. So we'll subtract 2. We'll divide by the -1. We'll square both sides, and then we'll subtract 3 over, so x equals 1. That's what we had. For the y-intercept, we'll plug in 0 for x, and we'll solve for the y, -0 plus 3 plus 2, and we'll just put that in the calculator. So negative square root of 0 plus 3 plus 2 is that decimal right there, so 0.27 is plenty. All right. So there's my x and y-intercept. Again, you could check it in your calculator. All right, this one wants to know what's the square root equation that matches this table. We want to first off look for the starting point. This is where it starts right here after the error. So it goes left 2. So inside the square, we're going to have x plus 2. That makes it go left 2. And then -7 on the outside makes it go down 7. From here, when we go right 1, it's going from -7 to -6, which is up 1. When we go right 4, it goes from -7 to -5, which is up 2. That follows the parent curve, where it goes right 1 and up 1, right 4 and up 2. And so there's no stretch, no compress, no reflection. That's my equation. And we can always check this on a multiple choice question, especially put in the answer choices into my y equals and see which one matches the table that's given. All right, number 9. Same thing. This is my starting point right here, so we're going left 5, x plus 5. We're going up 1 plus 1. This one, when we go right 1, goes from 1 to -1. It's going down 2. When we go right 4, it's going from 1 to -3. It's going down 4. Normally, we expect it to go right 1 and up 1, right 4 and up 2. But now instead of going up, it's going down, which means we're going to have a reflection. And it goes from 1 to 2 and 2 to 4, so it's a vertical stretch by 2. And there's my equation right there. And again, you can put this in y equals, check your table, make sure it works. All right, number 10. I want to get the radical by itself, so we'll add the 6 over first. We're going to get rid of the square root by squaring both sides. We'll subtract 1 over, and then divide by 7, x equals 5. And then last step, we need to check it. And so we'll put in -6 plus the square root of 7 times 5 plus 1. I put in my 5 for my x. That's the 7 times 5, and it should equal 0. It does, and so check that is correct. Number 11, the radical is already by itself, so we'll square both sides. 9 equals 1 minus 2x. We'll subtract 1. 8 equals -2x. X equals, divide by -2, -4. So again, we'll check it in the calculator. And so it should equal 3. We're going to do the square root of 1 minus 2 times -4. It does equal 3, and so it checks. There's my answer. Number 12, we got radicals on both sides. They're both isolated, so we're going to square both sides. It gets rid of the radicals. And now we'll solve it. So I'm going to add 6x over here, making it 7x. And I'm going to subtract 6 over here, making it -7. So x equals -1 after I divide by 7. And so if you wanted to see the work, I added 6x over here. I subtracted 6 right here. And then divided by 7. And then we'll check it. So on the left side, I'll just do this one mentally. If I plug in -1, that's going to be -1 plus 6, that's the square root of 5. Over here, if I plug in -1, that becomes 6. That again becomes square root of 5. It does check. All right, I can't really get rid of this 3 because I can't multiply it inside. I can't divide it to the other side, so we'll go ahead and square both sides. This square is going to go with the radical and the 3. And so we've got 7 minus 2x equals 3 squared, which is 9. -2 minus 3x. We'll distribute this 9. And then I'm going to add 27x over here, which makes this 25x. And I'm going to subtract 7 over here, which makes that -25. So x equals -1. And then again, checking it. I'll just do this one in the calculator. Make sure they're equivalent. Square root of 7 minus 2 times -1 is 3. And then 3 -2 minus 3 times -1 is also 3, so both sides are 3. It checks. Make sure to check your work. It's possible you could get some extraneous solution, so it's always important to check. We'll add this x over, so x minus 7 equals. We'll square both sides. X minus 7 squared, that's where you can come out to the side and FOIL it if you need to, but we need to multiply everything to everything, so that's going to be x squared minus 7x plus 49. So I'll put that over here, and I'll combine these to make -14x. Square root's gone, so 42 minus 6x. Anytime you have x squared, you have to move everything to one side. So we're going to subtract 42, and we're going to add 6x. And that's going to be -8x plus 7 is equal to 0. We got to factor this, so if you need to draw out the x, AC goes on top, B goes on bottom. So 1 times 7 is 7. -8 goes on bottom. We want to think what multiplies to the top and adds to the bottom. The only thing that multiplies to 7 is 7 and 1. To make it add to -8, though, both will need to be negative. So -7, -1. You divide by your a of 1, nothing changes. So x minus 7, x minus 1. And so we get x equals 7 and x equals 1. Those are my two x's. Now I just got to check it. I'll check it with the second line right here. X minus 7 is equal to square root of 42 minus 6x. And so for the 7, 7 minus 7 is 0. On the other side, though, if I plug it into my calculator over here, square root of 42 minus 6 times 7, that's also 0. It checks. So I'll put x equals 7 up here. Next off the 1, 1 minus 7 is -6. And I don't even need to check this side because I've got a negative equals a square root. That's not possible. A square root can't be negative, so the 1 actually doesn't check. Number 15, again, we'll add this x over. X minus 6 is equal to square root of x minus 6. We'll square both sides. So x minus 6 times x minus 6 gets me x squared minus 6x plus 36. So x squared minus 12x plus 36 is equal to x minus 6. I'll move the x over by subtracting x. I'll add 6. And so I want to try and think what multiplies to 42 and adds to -13. 6 and 7 come to mind. 6 times 7 is 42. It also does add to 13, so -6 and -7. And now we can check our work. And so x minus 6 is equal to square root of x minus 6. And so for 6 minus 6 is 0. 6 minus 6 is 0. 0 equals 0. Check. X equals 6. For the 7, 7 minus 6 is 1. 7 minus 6 is 1. Square root of 1 is 1. 1 equals 1. That checks as well. X equals 7. So both are correct answers. All right, number 16. You're going to have a bonus like this on the test. And so I'm actually going to skip it. I'll come back to it at the end. and I'll do number 17. Jill wants to build a rectangular pen for a dog. It gives us this equation, and it says F represents the feet of fencing, A represents the area. If Jill has 60 feet of fencing, so that's my F right there. What is the square feet? That's my area of the pen for a dog. So we're going to plug in what we know to solve for what we don't. The 60 is my F. I don't know the A, and so we'll solve for the A. If you want to, you can change the A to an X, whatever helps you out. So we'll subtract 15 over, and so we get 45 equals square root of A plus 225. All right, and then we'll square both sides. So 45 squared gets 2025. And then we'll subtract 225 from that to get 1800 is my area. And my units is square feet, and so feet squared. All right, now back to that bonus problem. This is going to be like a bonus because it is a little bit more challenging. We're going to actually have to square a couple times on this one. I can't do anything with this plus 1. I can't add it into the radical. I can't subtract it over here. And so we're going to go ahead and square both sides. This side becomes 3x minus 8. On this side, though, we've got the square root of, and I'll cut this off, 5 minus x plus 1 times the square root of 5 minus x plus 1. All right, so when we multiply these two radicals, the radicals cancel out. We're left with 5 minus x. But then we get plus the square root of 5 minus x plus the square root of 5 minus x plus 1. So this 1 and this 5 will turn into a 6. We've got the minus x, and then we've got 2 of these, so it's plus 2 square root of 5 minus x. All right, so let's isolate the radical. So we'll subtract 6 over, and we'll add an x over. So we get 4x minus 14 is equal to 2 square root of 5 minus x. There's two choices we can go from here. We can either go ahead and square both sides, or we can get rid of the 2 first. Either way is fine. Because these are divisible by 2, I'm going to go ahead and divide by 2 because that'll make my numbers smaller. So we get 2x minus 7 is equal to the square root of 5 minus x. And now we'll square both sides. So this becomes 5 minus x over here is equal to, we're going to have to FOIL once again. 4x squared minus 14x minus 14x plus 49. And so 4x squared minus 28x plus 49. And now we'll subtract 5 over, and we'll add x over. And so we get 4x squared minus 27x plus 44 is equal to 0. All right, from here we can try and factor this, or we can do quadratic formula. When I look at 4 and 44, those are some pretty big numbers. It may factor. I'd rather not just mess with it. And so we're going to go ahead and do the quadratic formula. So we're going to have negative b, which is 27, plus or minus the square root of. We're going to have 27 squared, which is 729, minus 4 times 44, all over 2 times 4, which is 8. I will simplify inside the square root, and so 729 minus 4 times 44 gets me 25. And now we can plug this in the calculator and get my 2 answers. And so for the positive, I'll put in 27 plus the square root of 25 is 5 over 8. And then for the negative, I'll do the same thing, just change it to a minus. So those are my 2 answers, 4 and 11 over 4. I'm going to change that to a decimal, 2.75. Then our last step is just to check it. There's a lot of work. That's why this is also a bonus. And so I'm going to check both these answers. So for the 4, I'm going to plug it into the original equation. So we got the square root of 3 times 4 minus 8 equals 2. On the other side, I've got square root of 5 minus 4 plus 1, which is also 2, so the 4 checks. Now I'll do the same thing with the 2.75, and so the square root of 3 times 2.75 minus 8 gets 0.5. On the other side, 5 minus 2.75 plus 1 gets 2.5. And so the 2.75 doesn't seem to work. 4 is my only answer on this one. And so that's it for our Unit 5 test. Good luck, and let me know if I can help.